Welcome to the general chemistry section of our practice MCAT questions. In this video, we'll be going through questions 1 to 5. So I'll quickly show the questions so that you can attempt them on your own. And now we'll be going through the questions together and going through the explanations. So question 1 is saying, according to the ideal gas law, which of the following statements is true about a closed system? So we're talking about the ideal gas law. We want to know which statement is true, and we're talking about a closed system. So a closed system is one in which matter can't escape. Energy can, but matter cannot escape. So that means our N, or the amount of moles that we have of a substance, is going to be constant. And we're talking about the ideal gas law. So what this is PV equals nRT. So you should definitely have that one memorized. And now let's go through the statements. So statement A is saying, at a constant pressure, an increase in volume will result in a decrease in temperature. So if we keep pressure the same, and then we increase volume, will we see a decrease in temperature? No, that's not correct, because you see, due to the ideal gas law, volume and temperature are proportional. So we wouldn't see a decrease in temperature, we'd see an increase. So that statement's incorrect. Statement B is saying at a constant temperature, so now temperature is held constant. At a constant temperature, an increase in pressure will result in a decrease in volume. Another way of writing the ideal gas law, you can write it like this. If you move volume over to the other side, you see that pressure and volume are inversely related. This is also Boyle's law. So because we know that pressure and volume are inversely related, we can say that, yeah, if we held temperature constant, we know that moles are constant, and then R is also gas constant. And then now we increase pressure, that will lead to a decrease in volume. So this goes up, this goes down. Yeah, that is correct. So option B is correct. A is incorrect. C is saying at a constant temperature, an increase in pressure will result in a decrease or an increase in volume. That's incorrect, because that would be assuming that they're proportional instead of inversely proportional. D is saying at a constant pressure, a decrease in volume will result in an increase in temperature. This is incorrect for the same reason that A is, because it is assuming that volume and temperature are inversely related, but we know due to the ideal gas law that they're directly related. In question 2, we're asked which of the following is not a type of internal energy. So internal energy of a system is the combination of all the different types of energy that there are. There are 3 main types of kinetic energy that we talk about. Translational, that is one, so we're looking for one that is not. Translational is if you have any particle and it's moving around in space, so it's going in any direction, that is a type of energy. Vibrational is also a type of internal energy, so this is just energy due to vibration in any particle or molecule or anything. That is a type. C is not. Refractory is not. Rotational it is. This is when that particle is rotating in space, so that is a type of internal energy. But refractory, that's not any type of energy. We don't have any refractory energy. Refractory more so is when we're talking about, for example, sound going from one medium to another medium, or light. Because of the different properties or densities of the media, it's going to be a different speed of travel for the sound or light, but that's not a type of energy. It's a different property, and therefore this is the correct answer for question 2. In question 3, it says a gas has a volume of 3 liters at 600 torr. What is the volume of the gas at 800 torr? Assume other conditions are constant. So for this question, if we know that we have one gas at some condition, 3 liters and 600 torr, we can figure everything else out due to the gas law, the ideal gas law. And now we are talking about changing some parameters and bringing the gas to a state 2. So this is state 2, and then state 1 is its initial state. We're told that all the other conditions are constant. The only thing that's changing are are the volume and the pressure, but the moles are the same, and then so is the temperature. So because of that, we can say that these two things, they're equal in the two equations. So we can set the other side of the equation equal. So we can say PV of condition 1 is equal to PV of condition 2. So those two things have to be equivalent if they both equal to nRT. So this is also just Boyle's law. After this, we just plug in the numbers that were given. So we're told that the initial pressure was 600 torr, and then we had 3 liters. That was equal to 800 torr, and it is at some volume. So we want to find out what the new volume is. So 600 times 3, we can just make that 1800, and then that was being divided now by the 800 torr on this side to give us the volume. So 1800 divided by 800, we can simplify that by dividing both the numerator and denominator by 100. So it's just 18 over 8. And then if we divide both the numerator and denominator by 2, we get 9 over 4 liters. That is our new volume. So our answer to this question is going to be A. So for this question, just know to use Boyle's law, or know to use the ideal gas law, and know which things are equivalent, so that you can make the two equations equal to each other, and then just plug everything in and solve. In question 4, we're asked which of the following compounds contains carbon at the highest oxidation state. So for this question, we need to go back to our rules for oxidation numbers and then solve to find out what carbon's oxidation number is. And all of these molecules are neutral, so that makes it a bit simpler. We know that hydrogen always has a +1 oxidation state. So if hydrogen is +1, that means that in total we have a +4 charge on this molecule methane in option A. And so carbon's charge to balance that has to be -4. Because -4 plus +1 times 4, because there are 4 hydrogens, is going to equal 0, and that's correct because we need to have an overall 0 charge, a neutral molecule. So -4 is the oxidation state for the first one. In this next one, we have +1 on the hydrogen, -1 on the chloride, because all the halogens have a -1 oxidation number, but there are 3 of those. So we have -3, and then the +1 gives us right now a -2 charge. Therefore, carbon has to have a +2 charge. In option C, we have +1 times 6. So there's a +6 charge. There are 2 carbons, so they have to have a +3 charge each, because there are 2 of them. And then now, a -3 charge over here. That will cancel out. So -3 on carbon in option C. And then finally, in this last one, we have a +1 charge times 2, so we have +2 on the hydrogens, and therefore we have a -1 charge on the carbons. So we're asking the question, which of the following contains carbon at the highest oxidation state? So that has to be the most positive number, and that is going to be option B. Option B was +2. All the other ones were minus something. So option B has carbon at the highest oxidation state. In question 4, it says that gamma rays are a type of electromagnetic radiation which involves the release of what? So we're talking about gamma rays and the type of particle that they release. So for this question, you need to know the different types of electromagnetic radiation, or electromagnetic decay, or radioactive decay, and what happens as a result of this decay. So what is the molecule that you get at the end, and then also what other molecule is released. Molecule or atom or subatomic particle, what else is released? So for alpha decay, you should know that a helium atom is released. For beta decay, it's an electron that's released. And then for gamma decay, it's a photon that is released. So that is just knowing the different types of molecules that are released for radioactive decay. So gamma rays, the answer is photons. That's it for the questions in this video. If you liked what you saw in this video and you want more questions with explanations for the answers, then be sure to check out our course on teachable.com. The link is in the description, and I'll see you guys in the next video.